Hi. So this lesson is on um, graphical and tabular displays for univariate data. So data that's just got one variable in it at a time. So in this lesson, we're interested in the distribution of the data. And a distribution is just any way of showing all of the possible values of the variable and how often they occur. It could be in a population or it could be in a sample. Either one. So we'll look at, for now, we'll look at distributions in samples, and then when we get to the probability section, we'll be looking at them in populations. So we need to look at three different kinds of distributions. One is for qualitative data. We'll get to that in a little bit. And then there's quantitative data. Within quantitative data, the distributions look different based on how many possible values there are. If there are only a few values where you could list them all, it looks one way, but if you've got too many possible values to list, it looks a different way. So let's start with quantitative data where there's just a few possible values. So I made up this data where we've got an exit poll taking place on election day. And as people come out of the polls, we ask them how many elections out of the past 4 did they vote. So out of a sample of 20, we collected this data. So everybody voted in at least one because they voted in the current one. So we had 3 people who said they voted in 1. We had 1, 2, 3, 4, 5 people who said they voted in 2 elections, etc. So let's go over to SPSS, and what we want is, and we did this before a little bit, what we want is a frequency table and a bar chart of the data. So let's go over to SPSS. Here's our data. If you remember, we've got data view and variable view. So we're looking at our variable with the name is number of elections, num elections, and the label is number of the elections of the past 4. And that's what our data looks like. We've got 20 observations, and there they are. So pay close attention to this. You might want to write down these instructions because you're going to need to do all of this in SPSS on your homework this week. So we're going to go to Analyze, Descriptive Statistics, Frequencies. And we're going to take this variable, move it over, and we want to check mark where it says Display Frequency Tables. That's going to give us our frequency table. So we want to leave that checked. And then under Charts, let's check Bar Chart. And you can either check frequencies or percentages. It doesn't matter. So click Continue, click OK, and then we'll go to our output window, and we'll take a look at what we get. So this right here is our frequency table. Tells us we've got 3 people who voted in 1 election, 5 people who voted in 2, 10 people who voted in 3, and 2 people who voted in 4. And we can see what this looks like on the bar chart. And just like you did before, right click on the output, click Copy As, EMF, and then you can go over to a Word document and Control-Alt-V to paste it. Click OK, and you can paste any of your output like that. Just like we did before, as always, if you cannot get your output copied into a Word document, just do a screenshot and paste that into the Word document. All right, so So back over here. That's what our output looked like. And let's talk about this a little bit. Let's see what does this tell us. So this tells us, and this is the kind of thing you're going to talk about when I ask you to tell on your homework what it tells us. This tells us that of the people they surveyed, so of the people in the sample, more people voted in 3 elections than any of the other values. It was the lowest category was 4, followed by 1, followed by 2, followed by 3. So it looks like not a whole lot of people. So just 2 people voted in all 4 elections, but most of the people voted in 3. Okay, so there's not a whole lot else to get from that. Nothing really profound. So that's what it looks like if you've got few enough possible values that you can list them all. So here again we just listed them all. Okay? Now, if you've got more possible values of a variable, for example, this is too many to list. So we're not going to list them all individually like we did before. So this is a data set that might represent the ages for a sample of, I think, 25 women who were prescribed hormone replacement therapy. So I created a relative frequency distribution here, and I didn't use any software to do this. I just did this by hand. And let me tell you exactly how I did all this. So like I said, there were too many possible values to list them all. So we categorized them. So we did 35 to 39, and if you look back at the data, there was just one person in the 35 to 39 range. So that was this one here, the person who was 38. There were 6 women in the 40 to 4 age range, 7 people in the 45 to 49 age range, etc. So that tells us what the categories are and then what the frequencies are. So to get the frequencies, I go back to the data and just count. How many were there in the 45 to 49? So there's 1, 2, 3, 4, 5, 6, 7. Okay, so that's literally all I do. We get the frequencies just by counting, and then to get the relative frequencies, we just do, there's 25 women in the sample, so we did 1 divided by 25 to get 0.04. We did 6 divided by 25 to get 0.24, etc. Okay, so this was just the percentage out of the total. Now let's talk a little bit about the class limits. The class limits, you wouldn't want to do 35 to 40, 40 to 45. You'd kind of like to go from 35 all the way up to 40, but not quite including 40. But if you did 35 to 40, 40 to 45, then you'd have some overlap, and you don't want the categories to overlap. So you're going from 35 all the way up to, but not including 40. So we just stopped at 39. These categories here, I would say we would describe them as starting at 35. So the first category is 35, and the width is 5. The width is 5, which means that the lower limits of these categories are 5 units apart. So 35, 40 are 5 units apart. 40, 45 are 5 units apart. Okay? So for this one, the instructions you would get would be use categories starting at 35 of width 5. Okay? I'll tell you, every time I teach this class, somebody says that should be 35 to 40, 41 to 46, 47, etc. Don't do that. Okay, so We'll talk more about that in just a minute. So, so again, category width is the distance between the lower limits of the categories. So we had a category width 5 because each category started 5 units after the previous category. In this one, the smallest data point was 38. So we had 38, and that was the smallest one. But I started the categories at 35 instead of 38 because I prefer to deal with round numbers. I think the point of doing a graph or a chart like this is to get a big picture view of what's going on, and to me it's easier to do that with round numbers. So for all of the ones that I give you, I'm going to ask you, I'm just going to say use categories of width whatever, starting at whatever, and then you'll just use that. You won't have to decide where to start, and you won't have to decide what category width to use. But the question does come up: how do you decide what categories to use? A couple things to keep in mind. You want to have a reasonable number of categories. Depending on how many data points you have, you want to have somewhere between 5 and 10. If you've got a larger data set, you're going to have more categories. And like I said, graphs should be easy to read, so I like to use round numbers. When we do these, when we do the histograms, the bar charts that go along with this, in SPSS, it'll create the categories for you and you won't have to worry about it. By the way, SPSS doesn't do this for you that I know of, so you just have to do this one by hand. So to get that table, I just I went to insert table just within this PowerPoint or within a Word document. All right, so this is a histogram. The histogram is a bar chart of the relative frequencies. So here we did 35 to 40, 40 to 45, etc. And this told us that there were, well, this was 35 to 39, but it shows it going up to 40, because remember we wanted to go up to but not quite including 40, and that's what's going on here. So this shows that we've got one observation here. We've got 6 observations in the 40 to 44 age range, etc. So the categories here are shown on the x-axis, the horizontal axis, and then the frequencies or the relative frequencies you could do on the y-axis. Let me show you how to get this in SPSS. So we've got this hormone replacement data here. I'm going to go to Analyze, Descriptive Statistics, Explore. I know there are other ways to get the histogram, but I want you to use this because this is going to be useful for us next week. So Analyze, Descriptive Statistics, Explore. We'll take our variable, move it over to Dependent List, and then under Plots, so let's click Plots. I don't want the stem and leaf, so we'll turn that off, and we'll turn on the histogram. And then we'll click Continue, and we'll click OK. And we will go look at our output window. And this is a histogram here. This shows different categories. I'm not going to expect that you know how to change these category widths. It's not that hard, but it's aggravating. So anyway, so this is how you do a histogram in SPSS. So you just move the variable over, You click on it, you follow those directions I just gave you. All right. So here's our histogram. The question is, what does this tell us? It's tempting when people look at a histogram to want to read it like it's a time series, like it's something that you've got somebody who starts out at a low age and then increases, decreases over time or something. But that is not what histograms are telling us. They're not telling us anything having to do with time. They're telling us that within the data set, here we've got not a lot of people under 40. Most of the people were between 40 and 60. We don't have a lot of people over age 60. So it looks like most of the people in our data set were between 40 and 60 years of age. So just back to the categories, what would those look like if you were asked to create categories that were of width 10 starting at 50? And what would they be if you were asked to create categories of width 20 starting at 500? So categories starting at 50 would be obviously starting at 50 here. And then width 10 means the next one starts at 60, the one after that starts at 70, and then you just make sure that these don't overlap. Okay, so 50 to 59, or if you want to do 59.9, I don't care. It doesn't matter. And then if they were starting at 500, for example, this would obviously be a different example, but your first category would start at 500, and then the one after that would start at 520, 540, so these would be 20 apart, and then you would go up to the next value. You go up to the next lower limit, but not quite. So you just want to make sure they don't overlap. So let's look at, and this is still for quantitative data. This is some distribution shapes. So take a minute and try to think about what each distribution tells about the sample. So pause this and try to see what, let's start with C. See what it tells about the data. So pause it and try to see if you can determine that. All right, so I assume you've paused it and you're back. This distribution tells us that there aren't a lot of values low or high. Most of them are in the middle. And the farther you get from the middle, the less common the variable is. Okay? So values in the middle are the most common. The farther away from the middle, the less common the values are. Now for the rest of them, for this one, all of the values are equally common. So it doesn't matter, whether the values are low, medium, high. They all occur with equal frequency. For E, this means that there are two peaks. There's a group of values that are low and a group of values that are high. And there's not a lot in the middle. I see this sometimes on tests where you get some people who really don't know the data or don't know the material we've covered, and then you've got other people who know it really well, and then not a lot of people in the middle. So that happens. For this one, the two peaks don't have to be the same height. They just, you could have one be a little more common than the other. Now for B and D, B, you've got low values being the most common, and then high values are uncommon, and then D is vice versa. Each one of these distribution shapes has a name, and this is what they are. This one is uniform. This one is right skewed. Think of this as right skewed means the long tail is out to the right. This one is left skewed, meaning that the long tail is out to the left. Bell-shaped, we'll see this one a whole lot this semester. And then bimodal, if you remember what the mode is, it means two modes. So two modes in the data. Okay, so be familiar with these and be able, when you see a histogram, to try to come up with which one of these is the best match. Now, those are general shapes. I'll tell you that real distributions really don't fit these very common at all. Here's an example from a real data set. This was the crime rates of cities in the U.S. Recorded as the number of whatever, it doesn't matter. So here's what the histogram shape looks like. You could say that this is skewed to the right. It mostly is, and that's probably what I would call it, but it doesn't neatly fit one of those examples. So just say, if you're asked to describe the shape, try to say which one it fits the closest to, but some of them just defy categorization. Here's another one. Labor force participation for different cities. This one, I'd probably call it pretty close to bell-shaped or mound-shaped. You might call it a little bit skewed to the right. It's hard to categorize that one. This one, you might call that bimodal, but I think this one, I would just say that one doesn't really fit any of the categories. So that's it for distributions of quantitative data. Now let's look at distributions of qualitative data. This one is distributions of car colors in a data set of 30. So we have a data set that's just car colors. So here's our data. And we're going to do exactly what we did before when we were looking at the frequencies. So the way we did it with data where it was quantitative, but there weren't a lot of possible values. So under Analyze, Descriptive Statistics, we're going to Frequencies, and we're going to do exactly what we did before. We're going to move the variable over. We want Display Frequency Tables checked, and under Charts, we want to look at Bar Chart. So click Continue, click OK, and then we can go over to our output, and we can see what the bar chart looks like. So we can see from this that black was the most common color. It looks like blue, red, and taupe were the least common, and then white and silver were kind of in the middle. Not a lot else we can say about that. By the way, the data here is qualitative, so we don't call this a histogram, it's just a bar chart. So what if I were to ask you, what is the shape of the distribution of car colors? It might be tempting to look at this and say, oh, it's skewed to the right or something, but But it's a trick question because qualitative data does not have a distribution. You could rearrange these colors into any order, and it would change what it might look like. So it does not make sense to talk about the distribution shape. Distribution shape refers to where are most of the values. Are most of the values low? Are most of the values high? Or are they in the middle? So we don't talk about distribution shapes for qualitative data. All right, so that's it for this lesson. Remember that anytime you're doing charts and graphs, the whole point is to look at the distribution of the data to give a picture of what's going on with the data. All right, so as always, let me know if you run into any trouble or if any questions come up.